Hello students, I'm Sage and I'm teaching the cultivation program here at the Cannabis Education Center at Holyoke Community College. Today we're going to talk about soil types, and hydroponics and how they affect cannabis. So first off, when we look at soils, we're looking at something complex. So I want to talk about soils first and how this will affect growing cannabis. Any type of agricultural endeavor starts with soil, and maintaining good soil and productive soil is incredibly important in today's agricultural systems. So this cross section shows different layers of soil with different size particles in it. You can see grass growing at the top here, roots extending down into the soil, and then different colors going throughout this soil. The top of the soil is called the O horizon, then the A, B, and C horizons are underneath that. Now, when you're studying agriculture and working in your fields, you're working mainly in the A and O horizons. Very rarely do we have to talk about the B horizons. So you will be looking at those in depth in your own agricultural system. A lot of people use the term topsoil, and topsoil refers to 5 to 10 inches depth of the topmost part of the soil. So we're looking at the O and sometimes the A horizons here. This is where microorganisms live. In this part of the ground. So our worms, our little beetles, this is where those reside. We also find a lot of organic matter in topsoil. So what's organic matter? Well, organic anything refers in science to carbon-based. So that also can translate to life-based organic matter. Organic chemistry is actually the study of carbon-based molecules. And that's a little bit different than how we use the term organic in everyday life, like referring to organic broccoli. It was grown without pesticides. Organic matter is just carbon-based material. And that can be breaking down leaves. Leaves are mainly carbon. The little microorganisms are carbon-based. So that's the stuff that we're talking about there. And when we look at topsoil, we'll see that topsoil will vary depending on the location. And it's a combination, most often, of silt, clay, and loam. And occasionally you'll find only silt, clay, or loam, but most of the soil that we look at is a mixture of silt, clay, and loam. This triangle is a soil triangle showing how we can break down the amounts of silt, clay, and loam in soil. So this is important because when you have pure clay in your soil, it will affect your plants in a certain way. Pure sand will have a different effect, and pure silt, another effect. So clay is called clay because it is the finest particle of soil. That's what determines it. Now, if you take a soil science class, you can memorize the exact diameter of a clay particle, but we're not going to do that here. Silt has a different diameter, it's slightly bigger, and sand is the biggest soil particle. So this is looking at the mineral soil, not the organic matter here. So sand is fairly big, clay is very small. What happens when you have all clay? Well, clay, because the particles are so tiny, can compact and get really close together. So that soil is easily compressible. You might notice that it is a very fine mud when you touch it, when you feel it in your fingers, and it will dry, often changing color, becoming a little more lighter as it dries. Also, when you have a field that's very rich in clay, and it dries out, it'll form cracks in it. So if you see that cracking, like in the desert, some deserts, that's an indication of clay. Now, sand has these really big soil particles. And when you have a lot of sand in your soil, there's a lot of space for water to drain through. So sand can add good drainage to your soil, but having pure sand is going to give you a soil that does not hold any water. Think of the beach And if you pour water onto the beach sand, it dries out immediately. And silt is in between there. So silt doesn't dry out that much as sand, doesn't pack as thick as clay. And you might think, oh, pure silt is very good soil. And it can be good soil depending on what type of agriculture you're doing. Most of what we have in Massachusetts falls in the middle, and the middle is really where we want to look for ideal soil types. Clay loam, sandy clay loam, silty clay loam. These are all really great for agriculture. Having a mix of those particles allows us to have the best of each type of particle. So a mixture of clay, sand, and silt allows us to maintain moisture, have adequate drainage, and allow for the roots to expand. Having a lot of space between soil particles gives your roots area to grow. Having compact clay doesn't allow for a lot of root elongation. Looking down here, I just want to point out that silt, clay, and loam all describe the soil's texture. And the points on that soil triangle are all the extremes. It's in the middle where we find good soils. Sandy loam and sandy clay loam are ideal for growing cannabis in our area. So that has the best mixture of particle sizes. But soils also contain different nutrients and different elements, even when we just look at the mineral component of the soil. But breaking down soil, we see that it's mostly carbon, hydrogen, and oxygen. We have oxygen in our atmosphere. It gets into the soil. Oxygen and hydrogen also combine to form water. And carbon, hydrogen, and oxygen form a variety of different organic materials. That's what we see in leaves, we see in our little critters, our microorganisms, insects crawling around in the soil, and subsequently breaking down in the soil. So our soil, the topsoil, will be rich in those three elements. Nitrogen, potassium, and phosphorus are also key elements for our soil to have. And we'll talk more about them in a nutrition class, our nutrition lecture for cannabis growing. But N, P, and K, which are the atomic symbols for those, N for nitrogen, P for phosphorus, and K for potassium, are very important elements for growing plants in any agricultural setting. We also have organic matter in soil for agriculture, decaying organisms, providing airspace, drainage, and micronutrients for our crops. So all of those can be found in the topsoil, all very important, adding different elements to our soils. Soil types, like I mentioned, will vary depending on where you are located. So a map of the United States can show us, when it's color-coded, where the different soil texture types are. And over here in Massachusetts, where Holyoke Community College is, we have a sandy loam soil. So our college is located right at this line between sandy loam and loam. Getting out into the loam, you're looking out into the Berkshires, a lot of sandy loam out towards the Boston area, and even some loamy sand. That would indicate that it's a little more sand than loam. When you have a descriptive word like that, sandy loam, sandy is the lesser component. It's more loam than sand. And when we look at that, we can see that we have a huge difference than what we see out in the Midwest, where we have more sand and we have some silt loam. And then we have Florida, which is very sandy down here, which isn't surprising based on its beaches, but really interesting to see in a map like this. We've got a lot of clay loam in Texas. So when you're growing crops, you want to know what you have in your soils. And Massachusetts can also have different pockets of kind of a microclimate for soils, different areas where we have different richness in the soil. So this is just a map looking at the different counties in Massachusetts and there's some differences in what soil types we have in the different counties. Of course, soil type does not stop at county lines, but each county has their own soil inventory. And so your assignment is to summarize the soil survey for your area by county. Please follow this link to the NRCS website. That's for the Natural Resource Conservation Service branch of the USDA, U.S. Department of Agriculture, and check out your soil survey. Give a little paragraph to summarize what kind of soil you have and what's found in your soil. So I'd like you to do that and then join me for part 2 of this presentation.